I'm going to talk about matrices, especially about transformation of matrices and diagonalization. So first, the basic concept is the linear transformation that is on page 10. And it's simply just changing a factor into a new factor. Like in this case, it's like from factor xy, that's the component, into a new factors. Well, possible case is like you know the r and you know the old factor and they ask for the new factors, so it's just normal multiplication. And the second case is we know the new factors, we know the old one, and they ask for the what is the transformation factors matrix, sorry. So it's just, and they will give this data. So the new one, the old one, the new one, the old one. And I usually do this. So I put R as A, B, C, D, and you multiply it normally. And in this case, you will get AC as the results of the multiplication, and AC equal to 1, 1. So A is 1, C is 1. And in this case, it's BD if you multiplied it. And B is minus 1, D is 1. So you will get the matrix. Now let's go to the transformation of matrix. Actually, in this case, you just need to remember the equation on page 26. That is this. And for diagonalization, quick reminder, symmetric matrix is A transpose is equal to A. And diagonal matrix is like identity. You have the component only on the diagonal. And for this case, the symmetric matrix make everything easier. So just with the word diagonalization, it's make the matrix into diagonal matrix. In the lecture notes, they give example matrix 2, 1, 1, 2, and the eigenfactors is this. So and then they put the R or the transformation matrix as this strange notation. This is actually E1 transpose, E1 transpose, and you put the component here. E2 transpose, I put the component here. So it's like this, and it's like this. And the new matrix, that is the diagonalized matrix, will be the eigenfactors, sorry, the eigenvalues on the diagonal component. This is actually quite simple and quite helpful because, sorry, something, this should be R. So you can actually switch this and you can actually put the eigenfactors any way you like. Just like you can put E1 here, here, E2 here, here, and you can put like this. And basically it's just for the combination, for all the combination, it's like only it will goes to a diagonal matrix, but just switching the eigenvalues. And for the quadratic form on page 27, it's like we don't need to know where this comes from. What we need to know is just when it's diagonalized, it will be like this with the new basis, and we will get the quadratic formula like this. And with this formula, it's like easier to plot the graph.